this section we're going to talk about methods for finding limits. So if you recall from last time, we talked about a limit being a value that the function is going to approach as we move from one point to another. So there's three methods that we can use to find limits. There's the graphical method, the numerical method, and the analytic method. The graphical method is exactly what it sounds like. We're going to use a graph to figure out what the limit is for different values of a function. So in this case, we've got a picture of a graph. Most of the graphs that you're going to see are not going to be quite this complicated, but here we've got a couple of different things happening. We have some jump points, we have some asymptotes, and we have some infinite values. Okay? So here let's look at a couple different limits. Let's look at the limit as x goes to -2 from the positive side. So in this case, here's our -2. We want to come in from the positive side. So remember, that means for the values greater than -2. So if I'm following my function from the positive side, we can see that the value is going closer and closer to this open circle. Now it doesn't matter that the function value doesn't exist there. Remember, for a limit, we only care what it approaches, not what it's equal to. So here we can see that the limit is going to -1, because that's where the function value is going. If we come in from the other side, so the limit as x goes to -2 from the negative side of f of x, same thing, there's our -2, except now we're coming in from this direction. So we can see it's going to follow the curve this way. So here, we're getting closer and closer to the closed circle, which is at a value of 2. So these were both one-sided limits that we talked about last time. And now if we look at the two-sided limit, the limit as x goes to -2, we can see that these values are not the same, or it's easier to see here. So we can say this limit does not exist. Okay. For the next one, if we look at the limit as x goes to 4, again, no plus or minus sign on there, so we're looking at a two-sided limit. 4 is over here on our graph, and so from both sides we can see as we come in from the right, things are getting more and more positive, and likewise as we come in from the left, things are getting more and more positive. Okay, so here these are going off to positive infinity. Okay. Another two-sided limit, so looking at the limit as x goes to 3, we can see on our graph from both sides, coming in from the right, we're getting closer and closer to 0. And likewise, if we come in from the left, again, we can see that the limit is going to 0. Okay. For the limit as x goes to 2, again, we've got the little negative sign there, so we're looking at the left side of 2. So there's 2 on our graph. Coming in from the left side means we're coming in from this direction. Okay? And here we can see the values, as we get closer to 2 on the x-axis, are getting more and more negative in the y direction. So here we can say that the limit is going to be -infinity. Okay? So those are all of our numerical ones, but we've also got what we call infinite limits. And again, this is doing the same thing. I'm looking at the graph and figuring out what happens as the x values go to a particular endpoint. Okay, so this is like end behavior of a graph. For these, even though there's no plus or minus sign, these are always going to be one-sided limits. If I'm looking at the limit as x goes to infinity, meaning positive infinity, I can only look at that coming from the left side of the graph. So if I move from 5 and move more and more positive, I can see that as I go to infinity in the x direction, my y values are going to -infinity. Okay? And likewise, if I look at the limit as x goes to -infinity, so on the graph, as my x values start at -4 and become more and more negative, I can see that the values are getting closer and closer to 0. So there's your first method, the graphical approach. This is a method that you will need to know. You'll see a couple of graphs on your exams and on your final where you need to be able to interpret what the limit is doing. Okay. For the numerical method, which is the second method for finding your limits, here you are using values to determine what's happening to the function. Some of these usually are ones that are not going to be as easily to graph. So, for example, 4 minus x over x minus 3, I could probably figure out what the graph of this looks like. But here I want to use the numerical method to try and figure out what's happening as x goes to 3 from the positive side. Okay. So the first thing to notice here is if I tried to plug 3 into this function, we see that the function becomes undefined, right? Because we'll get a 0 in the denominator. So note, 4 minus 3 over 3 minus 3 is undefined. So I can't just plug in. So here I'm actually going to take some values. I'm going to make a table. And basically I want to get values as they get closer and closer to 3. And in this case, I want that to happen as x is going to 3 from the positive side. So I want to start at values that are bigger than 3. So for example, 3.1. And I want to get closer and closer to 3. So one way to do that is to look at values like this. So 3.1, 3.01, 3.001. And I can go further in this table if I need to. But I just want to figure out what the y values are doing. What are they approaching as these values are getting closer to 3? Okay? So now all I'm going to do is I'm going to take and I'm going to plug these values into my function. Okay? This is why we call it the numerical method. We're going to actually numerically calculate what the limit is going to be. So if I plug 3.1 into my function, I find I get a value of about 9. If I plug in 3.01, I see that I'm going to get something about 99. There's going to be some decimal after it, but it's almost 99. And if I go to 3.001, I can see that I'm going to get about 998. Okay, and I can keep going. So, like I said, if you can't quite determine the pattern here, you can keep going with this. And so if I went one more, I would see that I'm getting something like, again, with some extra digits in there. These do have some decimals in there, so approximately. And so now I can see as I move closer and closer to 3, my y values are just getting huge. So here, I can comfortably say that my limit is going off to positive infinity. And this makes sense. We already know that it's undefined at 3, which means I'm looking at a vertical asymptote. And so it's got to be going to either positive infinity or negative infinity. And so in this case, we can see the values are all positive. It's going off to positive infinity. Okay. Let's look at a slightly different one. So this one is another numerical method, and again, I'm looking at an infinite limit. So the limit as x goes to infinity of 2x squared minus 3 over 4x squared minus 7. Okay. Here again, I can use my numerical method, because obviously if I plug in infinity, I'm just going to get infinity over infinity. And that doesn't tell me much. That's not a nice number. It could be many things. So here, I can take and again use some values to figure out what my limit is going to be. And in this case, since my limit is going to infinity, I just need to pick values as they get bigger and bigger. So I'm going to pick some nice values. Let's start with, say, 10, 100, and 1,000. And again, you can pick more than that if you need to, but I just need enough so that I can see what the function is doing. Okay? So in the first one, if I plug 10 into my function, I'm going to get about 0.5012. There's going to be some other decimals in there, so again, that's an approximate value there. If I look at 100 and I plug it in there, I'm going to get about 0.50012. Again, some other values after that. And then if I go to 1,000, I get something close to 0.5 with about 6 zeros, 1, 2, etc. Okay? And so then I can see, again, if I add more zeros to my x value, there's going to be more zeros added between the 5 and the other numbers in my y value. And so in this case, we can say that our limit, as I go off to infinity, is going to get closer and closer to about 0.5 or 1/2. Okay. Later we'll talk about other methods for determining the same type of limit. Okay. In this last example for numerical, we look at the limit as x goes to 0 of 4 over x squared. Okay. In this case, again, we can see that it is a vertical asymptote, so again, note 4 over 0 squared is something undefined. So again, we already know it's got to be positive infinity or negative infinity. But the difference here between the first example and this example is I'm not just looking from one side. So it could be that one side is going to positive infinity and the other is going to negative. We don't know until we test it out. Okay. So in this case, same thing, I can use some values. And here, because it's a two-sided limit, I need to consider both sides of 0. Okay, so if I'm coming from the left, I can look at things like 0.001, a negative 0.01, and a negative 0.1. Okay, so as I move this direction, I'm getting closer and closer to 0. And likewise, I need to look from the positive side. Okay, so same thing, from the positive side, I can use the same values and see what happens. And again, if I move this direction, I'm going to get closer and closer to 0. Okay. So, plugging in. So if I'm looking at, say, a negative 1,000th, I'm going to see that I get about 4 million. If I plug in a negative 0.01, I'm going to get about 40,000. And if I plug in a negative 0.1, I'm going to get about 400. Okay? Now I can do the same thing with the positive side, and what you'll notice is the only difference is when I'm plugging in, I'm squaring a positive number instead of a negative number, and so I end up getting the same values. Okay? So again, if I'm looking at these tables, what this is telling me is as I get closer to 0, my numbers here are getting more and more positive and bigger, and as I'm moving to 0 in this table, again, my values are getting bigger and more positive. So here, this tells me my limit as x goes to 0 of 4 over x squared is going to go to positive infinity. All right, our last method that we're going to talk about is the analytic method. Okay, the analytic method basically uses algebraic properties to find your limit. And for the analytic method, again, some of these you could use other methods like your graphical or numerical. But the nice thing about the analytic is I don't have to. I can usually just look at the function and apply some basic properties and be able to determine the limits. Okay. My first example here, limit as x goes to 4 of 3x squared minus 7x plus 2, I use to make a point. And I'm going to come back over here to the graph for just a second. if we look at the graph here and we remind ourselves what happened at, say, 3. So for this particular piece of the graph, I'm looking at basically a parabola. And notice, because there were no jumps or holes or breaks in the graph, when I went to find that limit, it turned out to be exactly what the function value is. Okay? So here, the same thing is true. If I look at the limit of a function where the value doesn't make the function undefined, or isn't causing a problem like an asymptote or something like that, then I can just figure out what the function value is. In other words, to find this limit, I can simply plug in 4 and calculate the limit. So in this case, my limit as x goes to 4 is going to be 22. And we can actually use the graph to show that. So you can graph that function, find out what your values are doing as they get closer to closer to 4. Or you can even use a numerical method. You can actually take some values as you approach 4 from both sides and find what the limit is. Okay? So these are kind of the nice ones. If I can just plug in and get your limit. In some cases, that doesn't work. So for example, in this case, if I notice, if I take a -2 and plug it into this function, again, I get something undefined. Okay? So this first algebraic property of just plugging in and simplifying doesn't work for all of your functions. But there are other algebraic properties, and this is where things that you learned back in algebra are going to come back to play. So things like, how do I simplify roots? How do I simplify fractions? How do I get rid of things like that? They're all going to come back to play here. And so in this particular example, I noticed 2 things. First, I have a fraction, and second, I have a square root in there. Okay? The problem with the fraction is that the denominator goes to 0 when I take the limit. But notice the top doesn't. Let me rephrase that. The top does not become undefined. I can plug -2 in for x, and I'm going to get a real value out for the top. So what this tells me is if I can somehow get rid of this root and rewrite it so that this piece is not the only thing in the denominator, then I should be able to find my limit. Okay? So algebraically, one way to do that is, in order to get rid of that root, I'm going to use what we call the conjugate. So remember, your conjugate is the same terms, just different signs in between. And I'm going to do both the top and the bottom so that I am multiplying by a form of 1. I haven't changed my problem that we've started with. Okay, but what I've noticed now is when I do that, I can combine the top, so multiply that out, and on the bottom, I'm just going to leave that alone for a minute. Okay. Now if I look at this, the top becomes an x plus 2. The bottom is an x plus 2 times our square root term. Okay. And the nice thing about this is when I look at this now, I've got a multiplication of like terms, so I can divide out those common factors. Okay. So my limit is now looking at 1 over the square root of x plus 3 plus 1. And again, if I look at that, now I can plug in that x equal -2, and it's no longer going to make it something undefined. So my limit will turn into 1 over the square root of -2 plus 3 plus 1, which in this root here is just 1. So 1 plus 1 gives us a limit of 1/2. Okay. So there's an example of an analytic method. The analytic methods, there are many different forms of it, and the difficulty with the analytic is just figuring out which algebraic method you're going to use to rewrite your problem. Okay. There are your 3 methods. Again, in terms of your homework and some of the problems that you're going to see from the text, you're going to look at all 3 methods. For the extension of this course, meaning what we're going to be doing throughout the course, the 2 main methods that you're going to want to know how to do are your graphical method, so being able to read information from the graph, and your analytic method, so being able to take a function and manipulate it algebraically so that you can get the limit.